Okay, so you already find out the change in temperature over here. Now you calculate what is the number of mole of copper sulfate. So you can use MV over 1000. Okay, then substitute in the information given. Okay, 0.5. Volume is 50. Divide by 1000, so you get 0.025 mole. So if you want to calculate what is delta H, okay, you have to find out what is the number of mole. Okay, so Q is equals to MC theta. So find out the value for the heat energy. So M will be the mass. So the mass over here is 50, like I taught you just now, 50 centimeter cube, and the density is 1 gram per centimeter cube. So when you times, you get the mass. So 4.2, and the theta is 27 degrees Celsius. Substitute, you will get 5670 joule, okay, which is equivalent, okay, which is actually equivalent to 5.67 kilojoule. So why I convert to kilojoule? Because you can see the answer given over here is in kilojoule. Okay, then the last step for you to find out delta H will be Q divided with the number of mole. So Q is 5.67 kilojoule. Divide with the number of mole, 0.025 mole. Okay, so when you calculate this, you will get 226.8 kilojoule per mole. Okay, so heat of displacement, if you see, it will release energy. Okay, and it's supposed to be negative value. Okay, so this is the amount of heat calculated. So the heat is actually released. So it's supposed to be boiled. So your answer is boiled. Okay, then moving on to the next question. Okay, paper 3. Okay, so I will cover up thermochemistry, paper 1, paper 2, and paper 3. So SVP, we can look at paper 3 straight away. Okay, so this is about heat of neutralization. Okay, so read the question. A group of Form 5 students conducts experiment in the lab to determine the heat of neutralization for the reaction between acid and two different types of alkali. Okay, two different types of alkali. The following are the procedure that has been carried out by the student. Okay, so they give you the procedure. So they put in hydrochloric acid. Okay, they put it into the polystyrene cup, and then after that, they put in potassium hydroxide. So strong acid with strong base. Okay, strong acid with strong base. And the thermometer is put in each polystyrene cup, and a thermometer reading is taken. Okay, potassium hydroxide solution is poured into a polystyrene cup containing hydrochloric acid. Okay, and the mixture stirred with the thermometer. After a while, the thermometer reading is taken. Step 1 to 5 repeated, replacing potassium hydroxide with ammonia. Okay, so you have to understand the whole process. They are using strong acid. So strong acid, the first experiment, they are reacting with potassium hydroxide. Strong acid, strong base. And then they are repeating the whole experiment with ammonia, which is a weak base. Okay. So for this experiment, take the manipulated variable. So manipulated variable, very clear. The base that is being used is different. So you can write down type of, since it's equals, type of alkali. Okay, you can write down type of alkali. Responding variable, what are you going to find out? You are measuring the temperature and so on. You are going to find out heat of, so be specific, heat of neutralization. Okay, so don't just write heat energy release. Okay, heat of neutralization. Okay, constant variable, what is left constant over here? So you can talk about the concentration or the volume of potassium hydroxide solution. Okay, so let's say concentration, okay, and volume of potassium hydroxide solution. Okay, and then other than that, what you can say polystyrene cup. Okay, polystyrene cup is used for both the experiment. Okay, so you have mentioned the variables. Okay, next section B, state one hypothesis. So the most important thing for you to find out is the responding variable. Once you already find out manipulator, responding, and fixed variable, you just have to relate them. Okay, so for hypothesis, you have to show the relationship between manipulated variable and responding variable. Okay, plus the direction, if you remember the previous class that I have mentioned. Okay, so now you're going to talk the reaction between a strong acid and strong alkali. Okay, so the reaction between strong acid and strong alkali, or you can mention, because you already know what is your strong acid and strong alkali. Strong acid is HCl, strong alkali is KOH. So you can straight away mention, okay, the reaction between hydrochloric acid and potassium hydroxide. Write down in sentence, hydroxide solution produce a, so definitely their heat of neutralization will be a bigger value. So produce a greater, okay, greater heat of neutralization than the reaction between hydrochloric acid and ammonia solution. Okay, so always have to mention both. Okay, so you have both experiments over here, always mention both. Okay, you are done with your hypothesis. Okay, then you have to, the next question, you have to record the reading. Okay, you have to record the reading. When you're recording down the reading, you should know this is a measurement for the temperature. So temperature means it should be, your answer should be given to 1 decimal place. Okay, so your answer, the reading should be to how many decimal place? It depends on the instrument. Okay, I also have given you in the previous slide. So it should be to, thermometer is 1 decimal place. Okay, so record down the data. Okay, initial temperature of the hydrochloric acid. Okay, so over here it's not so clear. You can refer to your own SBP paper. Okay, if you have a clear one. Okay, so the first one, for example, I just give you one. So initial temperature of hydrochloric acid is 28.01 decimal place. Okay, initial temperature of potassium hydroxide 28.0. Highest temperature of the mixture 41.0, and temperature change you just minus 30.0. So everything is 1 decimal place. So similarly you do over here, find out what is the initial temperature for the acid, okay, alkali, and then highest temperature, and then temperature change. So temperature change change over here is 11, 0. Okay, moving on. Okay, question D. Construct a table to record initial temperature of the solution. Okay, so they already say construct a table. You need to record down initial temperature of the solution, the highest temperature of the solution, and the temperature change for both experiment. Okay, so you have two experiment. So experiment. Okay, so I have experiment 1 and experiment 2. So they already given you what you're supposed to record down. So just write down initial temperature, of acid. Okay, and then you have to give the unit. Okay, degree Celsius, and then initial temperature of alkali solution, degree Celsius. Okay, and then highest temperature, okay, degree Celsius, and then change of temperature, highest temperature of the mixture. So be specific. Degree Celsius, and then the last one is the change of temperature. Degree Celsius. Okay, so you can get full marks. Okay, the next question E. Based on experiment 2, 3 observation. Got to state 3 observation, 3 respective inference. So observation, something that you use your 5 senses to find out. And inference is why from the observation. Why that observation happens. Okay, so this is how you relate them. Okay, so 3 observation you have to write down in the table. So the observation that you can see is that when they release heat, okay, so the polystyrene cup will become warmer, okay, or in another word you can say the temperature increases, thermometer reading increases. Okay, so you can write down, let's say thermometer reading is the thermometer reading increases, that is the inference. So because of exothermic reaction, or you can say because heat energy is released. Okay, heat is released. Okay, number 2, second observation, ammonia has a smell. So how do you write down the smell? You have to describe the smell as pungent smell. Okay, so the pungent smell of ammonia will disappear. Pungent smell of ammonia taken place. So why the pungent smell disappear? Ammonia solution neutralized. Okay, number 3, what are the other observation that you can see? Okay, so the mixture at the end of the experiment, if you find out the mixture, there is no change in color of the solution. So always remember, when you want to write down the observation, don't write there is no reaction. Okay, you don't know whether there is reaction or there is no reaction. Okay, but the color of the solution may not change. Okay, so if you write down There is no reaction, definitely wrong for observation. Okay. So why there is no change in the color of the solution? So that will be your inference. So neutralization, it will produce salt and water. Salt and water formed. Okay, or you can say salt solution is formed. Okay, so you write down the observation and also the inference. Okay, the next question. State the operational definition for the heat of neutralization for this experiment. Okay, so two things that you're supposed to know when you write down operational definition: what you do and what you observe. These are the two things that you have to relate with. So what have you done? Okay, what have you done? You put in the acid into alkali, okay, to produce water. That's what you have done. Okay, and then to see the heat of neutralization, what did you observe? You observe the thermometer reading increases, temperature increases. Okay, so this is you have to relate these two. Okay, so you can write down the temperature rises, the temperature rises, or you can say thermometer reading increases. Okay, temperature rises or the thermometer reading increases. Okay, when, what did you do? When acid is added into alkali solution to produce. Okay, so when you're talking heat of neutralization is very specific to the number of mole. Okay, so heat of neutralization is to produce 1 mole of water. Okay, so this is operational definition. This is your what you observe, and the second part over here is what you did. Okay, what you do, you have to combine these two. What you do plus you observe. Okay, then you can form operational definition. Okay, moving on. Calculate the heat of neutralization. So heat of neutralization is delta H for the reaction in experiment 1. Okay, so first step, what you have to do, definitely you have to calculate the Q. Okay, because delta H is equals to Q divided with the number of mole. Okay, so Q is equals to MC theta. Okay, so substitute in the values. Okay, the mass. So the mass, if you go back to the question just now, it was 50 gram. Okay, 50 centimeter cube of the acid, and 50, you can refer to the procedure. So you can see 50 centimeter cube and 50 centimeter cube. So that's going to make 100 gram. Okay, so 100 gram. So C is 4.2 and the temperature change. Okay, the temperature change is what you record down just now. Okay, what you record down just now. So go back. Okay, 13 degrees Celsius. So take in that information, substitute in for experiment 1, so 13, and then find out what is Q. You will get 5460. The unit is joule. Okay, now you have to calculate the number of mole. So number of mole of potassium hydroxide. Okay, so you write down, spell it out, NuMBER of mole of potassium hydroxide. So you can use MV over 1000. So MV over 1000, the concentration is 2.0 times 3 divided by 1000. So you will get 0.1 mole. Now you can calculate the delta H. Okay, so over here, 5460 divided by 0.1 mole. Okay, so heat of neutralization is always negative. So you can add the negative sign in front here. The negative and the positive sign is just to indicate whether it's endothermic or exothermic reaction. The amount of the heat is the numerical value. Okay, the numerical value. So 5460, that is the amount of heat that is being released. Okay, so you check in the question whether they ask the unit they want in kilojoule or they want in joule. So they didn't specify in the question. So you can write down the answer in joule per mole or kilojoule per mole. So you will get 5. So your answer for any heat, heat of displacement, neutralization or precipitation, you need to have the sign first. Joule per mole. Okay, so that is good enough. And you want to convert it to kilojoule means divide by 1000. So divide by 1000, you will get negative 54.6 kilojoule per mole. Okay. So moving on to the next question, question H. Okay, question H, they ask you to predict. So the experiment is repeated using solution R and solution S. Diagram 1.3 shows the pH meter reading for each solution. 10.5 and 4.5. Okay. Predict the temperature change when the solutions are mixed. Okay. So if you see, you have to predict with this pH value over here. Okay. How you are going to predict? .5 and 4.5. So 4.5 is considered as a weak acid. Okay. Strong acid means it's supposed to be pH 1, pH 1 is strong acid. Okay. And then same goes to alkaline. If it's a strong alkaline, it's 14, 13 or 14. Same goes to acid 1 or 2. Other than that, okay, when they are going near to pH 7, they are getting weaker acid and weaker base. Okay, so in paper 3, predict means you cannot say, you need to give a value. You cannot say it is less, the value is small. Okay, so you have to give a value. Okay, so for example, you can just say it is less than 11 degrees Celsius, for example. Because previously, it was the temperature difference over here. This is between experiment 1 is between strong acid and strong base. Okay, we will look at the experiment between the strong acid and weak base. Okay, so if you look at the experiment over here, it is 11 degrees Celsius. Okay, so predict means your value supposed to be less than 11. Okay, supposed to be less than 11. So you can say, you can predict as 10 degrees Celsius. Don't go too low. Okay, 10 degrees Celsius. Okay, less than 11 degrees Celsius. Okay, is good enough. You give a value, an indicator. Okay, when you say less means less than what? Don't say lesser. Okay, so that is predicting question. Okay, question I. Nitric acid is a strong monoprotic acid. You have to state the relationship. State the relationship between the type of alkali and the value of heat neutralization when react with nitric acid. Okay, so when you want to explain this, you have a strong acid HNO3, which is a strong acid. So they ask you to state relationship, okay, between the type of alkali. So type of alkali, you have two different type of alkali. Okay, strong alkali and also weak alkali. So this is what you're supposed to form a relationship. Okay, so you can answer the heat of neutralization of nitric acid and strong alkali, or you can give an example of strong alkali is higher than the heat of, so write complete the heat of neutralization of nitric acid and alkali. Or to give an example of weak alkali, you can go ahead. Okay, so you can show the same alkali. That means you can your strong alkali you can put as potassium hydroxide, no harm, and then your weak alkali you want to use as ammonia, also can. Okay. Okay, the next question. Table 1 shows the heat of neutralization of some alkali when react with hydrochloric acid. Okay, through experiment conducted in the lab. Classify ionized completely in water and ionized partially in water. So by looking at the heat of neutralization, you must be able to classify them. Okay, so you classify them into alkali that ionize completely in water. And alkali ionize partially in water. Okay, so alkali that is going to ionize completely, if you see the value must be higher. Okay, partially ionize partially in water, the heat of neutralization will be lower. Okay, so you can see 55 and 56.5. So you can classify W, Z. Partially means X and Y. They have lower value. Okay. Okay, this is MRSM paper you can try to do. So I think I will move on to salt. Because some of you requested for salt. Okay, we will go through SBP paper also. Okay, for salt. Okay, so we look at the objective question. Question number 10. A solution was tested with aqueous ammonia solution. A white precipitate which is soluble in excess ammonia solution was formed. Okay, so over here you have to know the test. Okay, when you use ammonia. Okay, so when you use ammonia, you will add in a little ammonia, then you will add ammonia in excess. Okay, so when you add ammonia in excess, you can divide all the cations into three parts. Okay, so Ca2 plus. Okay, so I'm sure you all have your own way to memorize this. Okay, Pb2. So if you don't know, then you can follow mine. So my way is Chari, Map, Map, Zoo. Okay, so Chari is calcium, Map is MAP, and Zoo is Zn2 plus. So over here, no change. If you have your own, then go ahead. Insoluble in excess and soluble in excess. These are the three observations that you can observe, okay, when you add in NH3. This is one of the tests. Another test, you can use NaOH. Okay, so when you compare all this, they ask a white precipitate which is soluble in excess. So zinc ion. So in order to answer this question, you need to know this. Okay, must memorize, must know. Okay, the next question is question 12. Which of the following is the most suitable reactant used to prepare calcium sulfate? Okay, so calcium sulfate, immediately when you want to prepare a salt, you have to know whether it is a soluble salt or an insoluble salt. Okay, so calcium salt is an insoluble salt. Also must know, insoluble salt. Okay, so if insoluble salt, you have only one way to prepare it. Okay, double decomposition, also known as precipitation reaction. Okay, so you need two soluble salt, and these two soluble salt will form precipitate. Okay, so your job now is to find out in A, B, C, D which are the two soluble salt. Okay, so calcium oxide and sulfuric acid, no. Okay, if you look at calcium carbonate, okay, over here they give you acid. Okay, even though if it's not salt, means you find out the solution. Okay, because they didn't give salt, they give you acid. So calcium carbonate and sulfuric acid. So calcium oxide is not soluble, wrong. Calcium carbonate, it is soluble. Okay, and sulfuric acid is also soluble. Calcium is a metal. Okay, and then zinc sulfate, not soluble, not soluble. So your answer is boy. Okay, question 14. The following solution have same concentration. Which solution has the lowest pH value? Okay, so lowest pH value means it is the strongest acid. So teach you now how to identify strongest acid. Nitric acid, hydrochloric acid, or sulfuric acid. Out of all three, sulfuric acid is the strongest because it's diprotic acid. Okay, so quite direct. Okay, the next question, question 28. The following are observation obtained for reaction of salt R. Okay. So a white precipitate is formed when R react with dilute sulfuric acid. So if it's a white precipitate form, means it will form insoluble salt. Okay, it produces insoluble salt. Okay, so they produce white precipitate. A yellow precipitate is formed when R reacts with potassium iodide solution. So when they say yellow precipitate, definitely it's supposed to be PbI2. Okay, PbI2 is the one that produces yellow precipitate. Okay, what is R? So it contains lead. It's supposed to be lead nitrate. Okay, it's supposed to be lead nitrate. And they say yellow precipitate, white precipitate, you have many different choices. Okay. Nitric acid is a strong acid. HNO3 is a strong acid. Okay. Then the next question, question number 18. So it shows apparatus set up in one of the steps to prepare a salt. So they use titration method. Okay. So titration method you use for soluble salt. Okay, so how to know which one is a soluble salt? Okay, all NH4 ammonia, sodium, and potassium. Okay, all these ions, salt that contains all these ions, you use titration method. Okay, so your answer should be ammonium chloride. Okay, soluble salt that contains this ion. Okay, so you can remember this as ANA. So ammonium, sodium, and potassium, soluble salt that use titration method. Okay. And the next one, 45, standard solution is prepared by using dilution method. Oh no, sorry. Okay. So standard solution means is a solution where the concentration is known. Okay, where you know the concentration, and you're using dilution method. What is the volume of distilled water needed to be added? Okay, I purposely put in this question because I want to show a careless mistake that always done by student. Okay, so what is the question is asking? What is the volume of distilled water need to be added to 40 centimeter cube of 1 mole per dm cube sodium hydroxide solution to produce a solution with 0.5 mole per dm cube. So you are using dilution method. Okay, so now you have sodium hydroxide solution, which is 40.0 centimeter cube per dm cube. Okay, so how much distilled water that you have to add over here to produce NaOH solution with 0.25 mole per dm cube? Okay, so you can use M1 V1 equals to M2 V2. Okay, your number of mole before and after, it is going to be the same. So you can use this relationship. So substitute in 5, you need to find out what is the volume. After calculating the volume, you get 160 centimeter cube. Okay, so what is this 160 centimeter cube? This is the total volume after dilution. Total volume after dilution. Okay, what is the question that they ask? What is the volume of distilled water needed? That means over here you have your initial volume plus with the volume of distilled water. Okay, volume of initial NaOH plus with volume of water. Total is 160 centimeter cube. Okay, so you have to find out the amount of water minus with 40. 160, when you want to find out what is the volume of distilled water added, 160 minus 40 centimeter cube. So the correct answer is 120 centimeter cube. So not this. Okay, make sure you are very clear about this. This is something that student always make mistake. Okay. Question 44. Diagram 44 shows a flow chart for the changes of few types of salt. Okay, barium chloride plus J, you will get barium carbonate. Okay, so barium carbonate plus L, you get barium chloride solution. What are solution J and solution L? So barium chloride to produce barium carbonate. This is a insoluble salt. So you have to combine with another soluble salt. Okay, so it could be, okay, M1V1 method, same as MAVA equals to MBVB also. Okay, it's just MAVA equals to MBVB. This one you use for acid, this one is base, when they have the same number of moles. So for example, if you see a reaction between HCl plus NaOH, you will get, okay, NaCl plus H2O. So if you look at the ratio between HCl and NaOH, the ratio is 1 to 1. So when the ratio is 1 to 1, you can use MAVA equals to MBVD. Okay, M1V1 equals to M2V2 is before and after. Okay, so before you are adding distilled water and after adding distilled water, your number of mole is going to be the same. Okay, number of mole is going to be the same. So same case over here also, the number of mole are the same. Okay, so when the number of mole are the same, then you can equate, because your initial equation is N is equals to MV over 1000. So your number of mole, first number of mole and second number of mole are the same, then you can equate this 1000 and 1000 will be cancelled off. Equal M2. So this is equals to M1V1 equals to M2V equals to MBVP. So that is the difference between the equation. Okay, this one you use for acid and base, this one you use for dilution method. Okay, the concept is because the number of mole are the same. Okay, so back to question 44. Okay, and then solution L. So solution L, you have a salt over here, and then you need to produce, you have to produce a barium chloride. Okay, so you have to react barium carbonate with acid. Barium carbonate, you have to react with acid so that you will form salt, water, and carbon dioxide gas. So your answer should be C. Okay, 44. Okay, section B. Question number 9. Okay, read the question, understand the question. Table 9.1 shows the observation from two different tests that are conducted on salt X. Okay, so you have to know all the tests for salt X. Okay. So you have test 1, the first test. Okay, you have salt X. Okay. Moist blue litmus paper turns red when it is placed in the boiling tube. So litmus paper turns red. So it is acidic. Okay. And then test 2, when a glass rod dipped into the concentrated hydrochloric acid is inserted into the boiling tube, white fumes is formed. Okay, so white fumes, when you put in hydrochloric acid and there is white fume means definitely it's supposed to be NH4 positive. There is a NH4 positive ion and the gas involved over here is NH3. Okay, ammonia gas and HCl gas, when they meet up, there is white fume. Okay, based on table 9.1, identify salt X. Explain why the moist blue litmus paper turns red. Okay, so identify gas X, you will get 1 mark. And explain why moist blue litmus paper turns red. Okay, salt X. So salt X. So salt X, if you see, there is ammonium ion. And then there is an acidic gas. So what is the acidic gas? So the acidic gas should be chloride. Okay, so salt X should be NH4. So they ask you to write down ammonium chloride. Okay, then explain why the moist litmus paper turns red. Okay, so if you see, there is presence of hydrogen chloride molecule. Okay, so when you heat up, there is presence of hydrogen chloride molecules ionizes ionize in water to form hydrogen ion. Okay, so hydrogen chloride molecules ionize in water to form hydrogen ion. This is the explanation to tell why the moist blue litmus paper turns red. Okay, there is presence of hydrogen chloride. Okay, question B. A student mix 50 centimeter cube of solution S with 100 centimeter cube of lead nitrate solution to obtain lead carbonate salt. Okay, so you have to give answer, suggest solution